Hello everyone. Today we are going to discuss about the cumulative distribution function for probability density function. In the last video we had discussed about the cumulative distribution function for probability mass function that is used for the discrete random variable, and today we are going to discuss about the cumulative distribution function for PDF. PDF means probability density function, so that we will use for the continuous random variable. So let's understand what does it tells. For continuous distribution, for CDF means cumulative distribution function, gives the area under the probability density function up to the x value. If you have this particular probability density function PDF and this is your x, and if you want to know only this particular area, then you can use the CDF to calculate this particular region area. So let's start the cumulative distribution function for PDF. So first understand what the formula we use in cumulative distribution function for probability density function. This stands for probability density function. Cumulative distribution function we denote by using capital F. So f of x is equal to probability is a random variable when the outcome is equal to or less than this particular random variable. So we can also denote like this: f of x is equal to your probability of x, this x is less than or equal to x. As I told you, by using this we can calculate the area. So area, you know, if you know the calculus, we use the integral like minus infinity to till x value, and this is your f of x and dx. This is your for the area, for area. So let's understand by one example here. So let's understand the cumulative distribution function by one example here. So this is your uniform distribution data set. We just draw uniform distribution data set, and this is called as your PDF function. This is your PDF function, probability density function. Density means all the area inside this. If we calculate the area inside this, the total area would be equal to 1. So let's cumulative distribution function corresponding to this uniform distribution data set. We want to calculate the probability when x is less than or equal to a. It means minus infinity to this a value. We have to calculate this particular value. So how we can calculate this? If you know there is no any corresponding data set before the a, so we can say that the corresponding probability would be equal to 0. If you see that this particular line, there is no any value, we are not getting any data set corresponding to this region, so we can say that the value is equal to 0. So till a, if we calculate the cumulative distribution function corresponding to this uniform distribution, so this is your point a. So from minus infinity to a, what would be the value? This is your 0, this is your 0 point. So we can say that minus infinity to till a point, your cumulative distribution function will have the 0 value. So now calculate if x lie anywhere between a and b. This is your x as lie at this point. So how we can calculate the probability at this point? So we can calculate the probability. First we have to calculate the probability minus infinity to a, then a to x. So as you know, how we calculate the probability means this particular area. So area from minus infinity to a will be equal to 0, and this area we have to calculate. So how we can calculate the probability from minus infinity to x? So we can say that, so how we calculate the area minus infinity to x? We use the integral function in calculus. Minus infinity to x, f of x dx equal to, we can write this equation minus infinity to a, f of x dx plus, we can say that a from a to x. We can write this f of x dx. This particular equation we can write by using these two values. So this is equal to, if we want to ask you what the value corresponding this particular equation, minus infinity to a, this is corresponding to your area. So area minus infinity to a will be equal to 0. So now we have to only calculate this value. So how we can calculate area a to x? Because this is your rectangular, if you see here. So area would be equal to a to x. So we can say that height into width. What is the width? Is x minus a multiply by, what is the height? 1 minus b minus a. So this is your the linear equation. This is corresponding to the linear equation. So now we can say that, so what we have to calculate the area corresponding to a and b. We have to calculate the cumulative function from a to b. From a to b. So we can write this equation corresponding to a to b fx dx equal to, we have to calculate the area a to b. So we can use this particular linear equation. We can replace this x value, with b. So we can say that b minus a multiply by b minus a. So this would be equal to 1. So we can say that this total area from a to b equal to 1. So we have to calculate the corresponding CDF. So we can say that if this is the value of 1, so this is the 1. So we have to calculate the CDF function corresponding to this particular area from a to b. So we can say that a to b. So at b point we have area corresponding to 1. Total cumulative value at b. What is the total cumulative value? We have 1. So we can say that if we want to calculate what is the area, this. So this total area is equal to 1, right? So we can draw this particular line here. What does this particular cumulative function denote? If we want to calculate the area, let's at this point, this is your, something value y. So we can say that this is also a y value, and let x is equal to y. So we can calculate the corresponding cumulative value. What would be the probability, or what would be the area from a to y? We can calculate by using this cumulative line. So if we know this particular value, this is your corresponding to 0.4. So we can say that at this area would be equal to 0.4. It means 40% area. So by using cumulative distribution function, we can calculate the area of any corresponding probability distribution function. So in this example, I use the uniform distribution data set, but you can use any data set. You can use this particular data set, or you can use the jumble data set. So any data set you can use, and corresponding cumulative distribution function you can calculate. And if you want to calculate this particular area, so this area can be calculated by using this cumulative distribution function. How can we use the CDF function to calculate the probability density function? Let's understand this. As you know, we have fx equal to p, x is less than or equal to x, or we can say that minus x infinity to x, this f of x dx. Like if we differentiate this, like your d, if this function, this f x corresponding to dx, we get this value. You can get the probability density function. We will verify how it works in our next example. So one more point you should consider, that it only works when we are able to get the derivative. We are able to get the derivative in CDF. If let's in this example, let's till here we have this particular graph. So are you able to get the slope or derivative or a gradient at this particular location? I think no. So this will work only till this particular. It means between A to B. When the x is greater than A and x is greater than B, it means x lie between A and B. Here you will also not get the gradient or a derivative at this particular point and after that, because there is no any low slope. So you will get A between A and B. So it tells that whenever the CDF is differentiable, we can get the PDF value. So let's understand CDF for probability density function by some other example. We have a population height distribution data. So let me draw a city population height distribution by using probability density function. So this is your f of x and this is your x. So these value we have corresponding to, this is your 165, this is your 190 and this is your 140. Corresponding you have 0, you have like your 0.01, 0.02, 0.03, 0.04 you have. So let me draw this. This is coming like this graph. So this is your height distribution in a city and this is your probability density function line. This line is called as this is your probability density function. So by using that we have to draw the cumulative distribution function here. So let me draw the corresponding CDF value. So we can say this is the capital F of x and this is your x. This is your 165, this is your 190 and this is your 140. Then cumulative, this is your 1 total cumulative. The middle value would be 0.5, this would be 0.75 and this would be 0.25. So the graph would be like this S type. If you convert this to in CDF, you will get some S like curve. 165 is your mean or median. It means when the x is 165, we can say that this particular area would be your, when the x is equal to 165, it means the area would be your 50%. This will cover the area, this will cover the 50% area. So we can say that when the x is 165, it means this value would be your 0.5. It's the cumulative, because as we had discussed in our previous example that cumulative distribution function cover the area. So the area covered at 165 would be 0.5. It means 50%. If we have some height, like some value here height, and if we say that what would be the area covered by this particular height, so we can say that the height at your 158. Okay, so we can check by this particular example here. 158 we get 0.25. So we can say that this particular area would be your 25%. So this way we can get the corresponding area by using the CDF. What is the probability, what would be the probability when we have height around, you can say the 180. Okay, so at this particular height, how much area will it cover? So this particular area, from this to this, so we can calculate by using this 180. We can say that if we calculate, this comes around, you can say around 0.8 8. We can say that the 80% area is covered. So by using cumulative distribution function, we can get the corresponding area. So this way we can get the how much area will it cover. Like at 180, the total area will be covered the 80% in this particular graph. So now if we want to like calculate the density, if I want to calculate the density function, probability density function from CDF. So how we will do that? In our last example, we had used like derivative of the CDF. If we have this particular slope, we want to understand the how much area. If we want to understand the how much area will it cover near to 165, like between these 2 points. This is your points, like this and this. We want to know the area covered between these 2 points. So we can do one thing. This is the value we have, 166 and 0.54. At this point let 154 and 0.46. okay, so these 2 points we have. And if we want to know the slope, what is the slope is that? Okay, so slope would be your this particular this value, like 0.54 minus 0.5, it means y value. This particular what will the value be? We will get this corresponding this value, 0.54 minus 0.46. it means slope or gradient we will get 0.54 minus 0.46 divided by this value, and it means from this to this, it means 166 minus 154, so this will come 0.04. so the gradient of the CDF, this is the CDF line, so gradient of CDF we get the PDF. This is your PDF. If you see 0.04, what the value we are getting at here, this particular, so what the value we are getting at 1.65, you can see it is coming 0.04. so it shows that we can use the differential of CDF to get the PDF. If we use like your d f of x dx, we will get the f of x. It means we will get the PDF value. This is your CDF. Now how to convert PDF to CDF? We need to use the integral minus infinity to x, then f of x and dx. This will be equal to f of x. So this way we can convert from PDF to CDF and CDF to PDF. So there is some property we have in cumulative distribution function. First one is it has the property of increasing. It is a non-decreasing function, So because we are cumulative the area, like what is the area we have, then again we are adding, then again we are adding. In this way we are running sum up like. So this way we can say this is a non-decreasing function or a non-decreasing in nature. Second one, if x tends to minus infinity, f of x is equal to 0. Third property is that if x tends to positive infinity, then your f of x value would equal to 1, like this. If it tends to positive infinity, it means it is equal to 1 value, or here equal to 0 value. So let's understand by using some another example. how we can calculate the PDF to CDF or CDF to PDF. Then we have PDF function like f of x equal to 3x square. This is the PDF function we have, and x lie between 0 to 1. So we need to calculate the f of x function. How we can calculate? Let this is your ft corresponding your t value, and let this is your 3 1 2 3, because we are getting the 3x square. So we need to do the parabolic. Let this is your 1. So we can say that this would be equal to something like this value at this. So this is your PDF. This is your PDF. So now we need to calculate the CDF value corresponding to this. If we have, let this is your x value. So by using CDF we calculate the area. So let's CDF, how we can calculate? Let's f of x equal to 0, like this is your 0. X is given as a 0 to 1. 0 to let x, f of t and dt. So we can say that this is your 0 to x and 3t square dt. So we can say that this is 3, then 0 to x t square dt. If we put 3, we get the x cube divided by 3, then we'll get the x cube plus c. This is called as a arbitrary constant value. So we are getting the almost x3. So let me plot this. You can plot this by using this way. This is your f of x, and this is coming as your x3. So this is your 1. This will be also the 1. So we can say that this would be your, like this type of the curve you will get. So by using this we can say that f of x would equal to 0. It means this will be 0 when x is less than 0. x3 when x is lie between 0 and 1, and it would be equal to after that constant 1 when x is greater than or equal to 1. So this way we get the 3 output of a single PDF function. If you have any question or any query, please mention in the comment section. I will try to answer all of your query. Have a nice day. Thank you.